Okay, question 3C is a tricky question, a hard question. But what we need is we need both aspects of question 3. We need question 3A and 3C because we're going to be using both these. And the question here is, find the probability that a randomly selected household in Hamilton, New Zealand has more cars than a randomly selected household in Hamilton, Canada. So there's a number of ways that you can look at this. I mean, the options for both of these is that they have 0 cars, 1 car, 2 cars, 3 cars, 4 cars, and let's say that's for Canada, and 0, 1, 2, 3, 4 for New Zealand. Now, we need, I don't know what the best way to set this thing up, if it's a tree diagram or a table or whatever, but basically what we need is we need the probability in every instance where New Zealand has more cars. So we can't really use the whole where New Zealand has 0 cars because that's just, there's not going to be anything there that works. And the only time that New Zealand will have more cars than in Canada is in this combination here where there's 1 New Zealand car and 0 Canadian cars. And then there's really no other time that there's a situation there where New Zealand has more cars. And then where New Zealand has 2 cars, you can have 2 versus 0, and you can have 2 versus 1. And really, that's it. That's all the opportunities or chances of that happening where you have New Zealand again having more cars than Canadians. And then where you have 3, you can have 3-0, 3-1, 3-2. All this showing that New Zealand has more cars. And then with 4, obviously you can have 4-0, 4 versus 1, 4 versus 2, 4 versus 3. And then that's it there. So what that is showing you is all the different combinations where New Zealand has more cars than Canadian cars. All right? I suppose the other way of looking at this thing is you could, I suppose, draw some sort of tree diagram. If you were to go, this is New Zealand, and this is the number of cars, 0, 1, 2, 3, 4. Now, really, we don't need the 0, so we can leave that out. And then if we work our way across the branches here, this would represent now Canadian cars, okay? And we don't need to deal with 0. So this is the only time that in this situation when New Zealand has more cars than Canada. And then if we drew it here, we would have 0 and 1. And if we drew it here, we would have 0, 1, 2. And then I've run out of space, but you get the idea. You have 0, 1, 2, 3. And see, what happens is that you're going to have to figure out what the probability, use the probability of, say, getting 2 and 1, and then times it, because you're going to be moving across the branches, times it by the probability of 0 Canadian cars. And so let me just show you, let me just show you one branch, one situation from this. So here's the number of cars in New Zealand, and there's 1, okay? And then where is it big? The only time that it's bigger is when you combine it with the combination of Canadian cars having 0. There being 0 Canadian cars. Now the probability in New Zealand of having 1 car is 0.298. And the probability of having 0 cars is 0.059. So all we do is we go 0.298 times 0.059. And that is 0.017582, which if you take a look at the questions is exactly what they have for the very first part. Now what are we going to do to that? Well, we're going to take a situation where we have 2 cars. Now Canadian cars can be 0 and 1. In both those instances, New Zealand cars are still bigger. So you look where New Zealand is 2, it's 0.423. And then where it is 0, 0.059, and where it's 1 is 0.383. Okay, so now we have a situation where we have 0.423 times 0.059, 0.423 times 0.383, and then you would add those together, and I don't think that works. Now I just checked the answer and it does work. So if you go 0.423 times 0.059 and 0.423 times 0.383, and then what are you going to do, obviously, is add those together, and you get 0.186966. And if you check the answers, that's the second part of the question, the second value that they add together. So again, if we take the next situation, which is where New Zealand has 3 cars, in the situations where that's the probability of having 3 cars is going to be greater than having 0 or 1 or 2. So again, you work out the probability, 0.119, for New Zealand having 3, and then you've got the same values here that you had before, 0.059, 0.383, and 0.377. And then you would work that all out, 0.119 times 0.259 plus 0.119 times 0.383 plus 0.119 times 0.377. And you add all those up and you get the next set. And you would do that until you went to 4. And when 4, you would have a situation where it's less than 3. So 0, 1, 2, 3. And you work all those probabilities out. And you just it's like a tree diagram, or it could be a table that you work out and so on. But it's finding these probabilities, these situations where when is New Zealand cars more? When are they more? And what would be the probability of that? Then you would have to add those all together.